Welcome to the Inside UMSL podcast. I'm your host, Nate, and I'm joined today with Dr. George Nnanna, the founding director of the School of Engineering at UMSL.
Thank you so much for having me.
I'm happy you're here. How you're doing good today?
Yes, I am.
Wonderful.
Very
Well,
good.
let's go ahead and jump right in. So if someone were to ask, like, what exactly do you do in your department, how would you explain it? And try to explain it in a way that someone like me would understand.
Well, what we do is building a new curriculum in the School of Engineering that focus on experiential learning and hands-on experience in the areas of civil engineering, mechanical, and electrical.
Okay.
So we've done strategically try to integrate theory into practice so that the students will be able to test the application of science, math, and engineering in solving real-world engineering problems.
Okay, so you said that it is a new cohort. So seeing as you're the founding director, this is a completely new area of study at UMSL.
Yes, it's brand new. So we admitted the first cohort of students, 60 students.
Wow.
In fall. We were estimating about 50, so we have 60 students. And these new cohorts are now taking engineering classes, including elementary engineering design, which is really brand new for them.
So seeing as this is the first cohort ever, what is something that you're very excited about coming up with this group of students who are entering into the new engineering program?
Well, I'm very excited to see them experience the new engineering within UMSL and also to see them go into the workforce. The UMSL engineering, I believe, is very transformative in terms of socio-economic mobility, trying to prepare the students to go into the workforce and support the regional economy. So the school was actually started from funding received from the state of Missouri, as well as support that we received from the James S. McDonald Foundation. That has really been the catalyst in the development of the program. We are also looking at renovation of about 20,000 square foot space. So that's 20,000 square foot space is going to house civil engineering, mechanical, as well as electrical. But the unique feature of that space is the design studio. The design studio is going to house a number of machines that will enable the students to go from concept, ideas, to innovation, to fabrication and testing. So that will really be transformative for the students.
What are some of the machines that help them go through that process that you're looking forward to putting in place?
Like we're looking into 3D additive and subtractive manufacturing. We're also looking at CNC machines. And then scanning electron microscopy so that they'll be able to test the properties of materials.
So an electron microscope.
Yes. Yeah.
That's super cool.
Yeah, and that's really unique for undergraduate students. Because in other places, they will focus that on the graduate students. But here we're trying to bring the students in from day zero to have a hands-on experience, learn about these machines, and then go into the workforce.
Now, when they're going into the workforce, what is it that you're doing within the program that helps them prepare themselves for those real-world problems that they're going to face?
So we're partnering with a number of industries, like the Advanced Manufacturing Innovation Center here in St. Louis. And we've worked with Boeing and robotics company like HTE. So they give us real-world problems that the students can solve. And also we're looking into internship opportunities for the students. So while they are doing some research work in the school, they are also performing internship. So by the time they graduate, they will be fully ready for the workforce.
So you have a lot of your programs in motion now, and you have a couple of programs. Is there anything that you're looking to add in the future?
Yes. So construction management is really key in this region. So as we progress with these three programs, we will be looking into adding a construction management degree program. There is high demand for it.
Okay.
And there is a high demand for advanced manufacturing.
Okay.
Corporations like Boeing will have a high demand with their F-47. So the School of Engineering here is well positioned to have programs that support the local industry as well as in the area of construction management.
Can you just for me describe the construction management and the advanced engineering? Like, what are aspects of those that make them different from civil, electrical, and mechanical engineering?
So the construction management focuses on managing the projects within the construction industry. So it can be carved out from the civil engineering.
Okay.
So instead of focusing on structural analysis or building bridges, it focuses on the management of those projects. So you can take some classes from business and engineering and put them together to give you the construction management.
Okay.
In terms of the advanced manufacturing, it's really an arm of mechanical engineering.
Okay.
But here you're focusing more on additive manufacturing, whereby you continue to add components layer by layer, or the subtractive manufacturing, where you're subtracting materials in order to produce a part. There is a high need for the workforce in this area of advanced manufacturing. So we're doing things like digital twin, doing simulations on computer, and then students can be able to export those programs to CNC machine in order to fabricate it.
Now, you made mention earlier about how you're trying to teach students to take theory into the practical application of it.
Yes.
What is that process in leading them through that?
The process begins with conceptualization, defining the problem, and identifying a problem. And then from there, you look into the review of literatures to see what has been solved and the way it has been solved. And then you can think of how you can make a contribution to make a change. Let's say that you're redesigning a wheelchair that will enable someone to be able to pick up an object. So you can integrate a robotics arm into the wheelchair. So to do that, you have to think about those mechanisms that will enable you to do that. And then from the design, you do an iterative process to see which of the design is optimized. And then you take it into the design phase using a Autodesk software to design it, and then you simulate it to see how it performs on the computer before it goes into the fabrication phase. So it's really from idea all the way to fabrication.
And this doesn't sound like the type of project that is just one person working on it. It seems like it's a team, correct?
Absolutely. This is a good question because one of the things engineering emphasizes is teamwork.
Okay.
And not just teamwork, interdisciplinary also.
Yeah.
So bringing in somebody from mechanical and electrical or someone from business that can also look at the marketability of that product. So it's really a multidisciplinary, interdisciplinary team that we're trying to create.
And then with this teamwork, that means that someone's going to have to lead the project. How in your department do you teach leadership? Like what is your angle on how you teach people how to lead teams to get a product from idea to completion?
So we intentionally put together a group of students. So we typically will ask them to discuss among themselves and identify a lead.
Okay.
So, and then they can divide that project into subsections, and each individual will be in charge of one aspect of that product.
Okay.
And then from there, they can integrate whatever products or sections that they are working on into a more holistic project.
Yeah.
And then that leads into regular meetings and also presentations, because we assign a project and then they have to give a weekly report on how they are progressing. So that way we monitor them and provide feedback.
Now, with the students that you're trying to teach leadership, what are some hallmarks that you think are signs of a good or strong leader?
A sign or hallmark of good leadership is
Mm-hmm.
communication.
Okay.
Communication is very key, and the ability to accept, to be open in accepting new ideas, and also realizing that you're not perfect, that you can make mistakes. So if you can be able to communicate your ideas and listen to others, that's really very key in leading the team.
It's interesting that you're completely okay with mistakes, and it's about how you operate with those mistakes. How does that work within the engineering world? Because sometimes mistakes would mean like a failed project or something like that.
Yes, a mistake may feel like a failed project, but through those failures, you can better the design. So in research or in innovation, failure of a product doesn't really mean that it's not going to work. It just gives you an opportunity to look at it from a different perspective. So if you don't dwell on the failure and identify what you can learn from it and improve on it, that's really the key.
I like that a lot.
Yeah.
I like that a lot. Now, with your students, since this is a new program, do you already have an idea of the next steps for them as they move throughout the engineering school?
Yes. So intentionally, we have embedded research, innovation, and entrepreneurship throughout the entire curriculum.
Okay.
So in each year, they will be engaged in research. And as they progress in second year, then they start exploring internship opportunities. And when they go into third year, they are now more conversant with the details about their specific disciplines.
Okay.
And we can engage them in research expo that will enable them to continue to progress. But we are not just stopping at those students within the program. We are also expanding into K-12 outreach,
Okay.
reaching out to students in high schools. Last summer, we performed an outreach activity whereby we brought in about 33 students from 22 local high schools.
Wow.
To expose them to various aspects of engineering. And about 7 industries participated.
Wow.
Next year, we're going to also do the same, but also expand even further to 6th to 8th grade students.
Okay.
Yeah, because if you don't bring in those students earlier on, they may miss out on opportunities to be in the engineering program.
Okay. So when you think about leaders who shape the future, what are the hallmarks of a leader who is part of what's shaping the future and hallmarks of one that isn't? So what are some leadership qualities that you think make a really solid leader that changes things in the future?
The hallmark of a leader that changes things in the future is, again, somebody that is capable of identifying problems, building up a team. Not just a team that agree with you, but a team that can disagree with you and you can listen to them and learn from them to build. I have a participatory type of leadership strategy.
Okay.
Where everybody is engaged in the decision-making process and is also collaborative in nature. So by doing this, you see that individuals bring ideas and you can go through them and identify the positives and negatives and build upon that.
Okay.
And I also appeal to the shared governance strategy. So the shared governance, meaning that individuals have a stake in the leadership of the school, because we can rise together or we can fall together.
Yeah.
So by having a shared governance strategy, each individual is a leader within the organization, bringing ideas and then we discuss it. Having shared governance doesn't mean that you cannot make the final decision. So if you bring in ideas, I will take a look at it. At the end of the day, I make the final call and I'm responsible for that.
When making the final call on a decision where there's multiple right answers, there's no one right way, how do you decide among the multiple right answers? It's a complex decision.
It is a complex decision. What has been helpful is to weigh the pros and cons.
Okay.
So I will put the pros in one bucket and then the cons of each of these ideas, and then analyze them. And before the decision is made, I will call the team to let them know that this is where I am heading, and this is the reason that we are heading this way. Sometimes it cannot be that analytical.
Yeah.
Sometimes you have to respond to the need of community or to the need of the university.
Okay.
But you have to let the team know, while you have a good idea, but this is the vision of the institution, and this is why we are doing it this way.
Okay. So it's balancing the needs of multiple different areas is kind of how you're shaping your leadership decisions.
Yes. So you have to consider the constituencies that are involved in the decision making. For us, our constituencies include, among others, the students. That's our primary constituency. Then the faculty, the students, the university that you serve. So you take all these into consideration as you're making the decision.
And what shaped your leadership style? Was it a book or a quote or someone that you know? Like, how did you become the leader that you are today?
I think from experience.
Okay.
I started my leadership journey at Purdue University as the department head of mechanical and civil engineering.
Okay.
So there I led a number of faculty as well as about 400 students. So as you move along, you make mistakes, and then you learn from those mistakes and continue to fine-tune.
I like that your approach is all allowing yourself to make mistakes and not just stopping at them, but learning from them.
Yeah. No, that's very critical, because nobody is perfect. If you accept that imperfection and see how that can help to bring you closer to perfection, that's really the whole strategy.
As close as you can get to perfection.
Yes.
What are some things that you do now to continue growing your leadership skill?
I continue to do professional development.
Okay.
To learn from others. I'm fortunate I have good bosses that I report to, the provost, the chancellor, or even horizontally from other deans.
Yeah.
So you learn what they are doing and see how you can improve yourself. I'm currently the commissioner for ABET, that's the accreditation agency.
Okay.
In the area of mechanical engineering. That also involves significant leadership, in terms of traveling to other universities to look at their programs, engineering programs.
Yeah.
And make an evaluation whether it is worthy of accreditation.
And with everything you're saying, what are the qualities of a leader, like the descriptive qualities that you would say make a really strong leader?
I think it's multiple qualities. I will circle back to listening.
Okay.
I will circle back to empathy.
Okay.
You have to show that care. And you have to have a vision. You have to have a vision of where you're taking the organization to. And then time management is also critical in leadership.
And from what I've heard, it seems like humility is a big thing that's a part of it too.
Huge.
Yeah.
Yes. Yeah.
When you make mistakes, how do you communicate that to the people that you're working with?
I have transparency style of leadership.
Okay.
If I made a decision and if it didn't work, I'll bring the team together and tell them that these are the mistakes. This has failed.
Yeah.
But then it's an opportunity to look into it to see how can we do better.
Yeah.
Because if you don't tell them, they will find out.
It's very true.
Yeah. So it's best that you tell them rather than finding out on their own. So
that's a very good idea.
Yeah.
And so are there any books or anything that you're reading that are inspiring the leadership that you're working through?
A colleague gave me a book. I can't think of the name. That was years ago. But it was like a case study
Okay.
of various scenarios within the academia. And I also took a class in leadership at Oxford University.
Okay.
Yeah. And a course at Harvard that focused on academic leadership.
Okay.
I think those has been very useful. I refer to those notes periodically.
That's cool.
Yeah.
Now, I noticed that you've brought with you something that you're working on with your students, correct?
Yes.
Okay, we talked about it a little bit before we started, but can you give kind of like an introduction of what it is that you're working on?
Yes, absolutely. So what we have here is a robocar.
Okay.
In the freshman engineering, we introduce elementary engineering design. So this involves electrical, mechanical, as well as civil engineering students. So we teach them how to apply math and physics in order to design an engineering system. So here they have fabricated and assembled this device, and then they programmed it using our Python language. And in the next couple of weeks, they will be doing a robocar race, so whereby they can compete with each other and determine which one moves the fastest. So this can be controlled actually using my cell phone.
Okay.
So we have the IP address that is embedded here that I can program it and then instruct it to turn left or in any direction.
Yeah.
And it will be able to do so. So what is unique about this is that the students are learning from day one how engineering works.
Yeah.
And how you can be able to program on your own. So these typically are shifted further in their curriculum, but we intentionally brought it forward.
Yeah.
So this will then enable them in order to do more advanced stuff in the future. So that's one aspect of our experiential learning. And in the next 8 weeks, they are going to be focusing on 3D printing. So we will give them exposure on additive manufacturing as well as subtractive manufacturing. So the idea here is embedding research, embedding hands-on experience, and bringing in the industry so that they can interact with practicing engineers to see what their day-to-day activities look like. So we asking them to, from now, to look into the future and see what your day will be like.
That's super cool. Yeah, that I remember building with Legos and making something similar to that when I was younger. So that seems very complicated compared to what I had to do.
Thank you. I think the students are really having fun here. So
yeah, that's super cool. After this, I would love to see that thing drive if it can.
Okay.
Yeah, I would love that. So to move into another question, what do you love most about being a part of UMSL in the St. Louis community here?
What I love most, or what brought me here, is really when I looked at the opportunity and see that there is a great need to help the community, first in developing this program, but also in the area of socioeconomic mobility. And also that having the industries we have here is really fitting to have an engineering program. So since I've been here, I've worked with Office of Advancement in reaching out to the industry and getting supports. We recently have support from the Beige Family Foundation that is providing opportunity to support the summer camp that we are running. We also had the James S. McDonough Foundation that is supporting scholarships. And we brought in a Mechanical Contractors Association, and they are supporting students in scholarship. And the students have formed the Formula SAE car, a club. And also they formed the Robotics Club. So in the next few years, you will see them designing and fabricating the race car so that they can compete nationally.
That's cool. It sounds like the perfect intersection of your engineering background and your leadership because you identified a problem and now you're working through the process on how to solve that problem.
Absolutely.
That's
Absolutely.
really cool.
Yeah.
Now, if you had a free weekend in St. Louis, one whole weekend from Friday night to Sunday night to do anything you wanted, what would you do here in St. Louis?
Well, I still have not gone to a soccer game.
Really?
Yes. So if I have a free weekend, I think that will be top on my list.
So you would go catch a soccer game
Yes.
for the weekend
Yes.
because you play, right?
Yes. Yeah. When I was in secondary school, I was forward. So
I like that.
yeah.
I like that. Well, thank you so much for joining me. This
Well,
has been a really, really fun conversation. Thank you.
Thank you for the opportunity. I appreciate it.
Absolutely.